Hello, today I am going to talk about the research paper Detection Tool Return-Oriented Programming Defender written by Lucas Davey and his team. In the research paper, Davey and his team discusses about the increasing return-oriented programming attacks, techniques, and the need to use practical tool as ROP Defender to detect ROP attacks. The modern runtime attacks are the cause of increasing ROP attack, which are so powerful that it cannot be prevented even under the situation where there exists modern memory protection mechanism such as data execution program. On the other hand, ROP Defender is a solution presented in the research paper to defeat the ROP attacks and a tool which enables end users to detect ROP attacks. Since ROP Defender does not depend on the site information as source code or debugging information, it is easy for end users to deploy it at any time. The research paper discusses about the methods and processes in implementing the ROP Defender to defend ROP attacks. Firstly, the researcher discusses about the main assumption for adapting ROP Defender model. The first assumption was that the adversary can issue ROP attack that cannot be detected by the compiler. Another assumption was no access to site information in the process of defending the attacks. Moreover, the assumption as enforcement of the W+X security model in operating system is also made. Lastly, the existence of trusted computing base in case of tool tampering by the adversary. The authors of the research paper also presented instrumentation as tool and techniques to detect ROP attacks. They use instrumentation as it adds additional code to a program and helps in debugging program nature. They also use shadow stack for purpose of storing copy of return address after the function is called. In addition, they instruments all return instruction at the time of program execution and check return address, which help in detecting not only ROP attacks but also detects any violations in a return address. Basically, they focus on the use of dynamic binary instrumentation at runtime for avoiding the access to site information. There are two kinds of dynamic binary instrumentation: probe-based and just-in-time compile-based. Probe-based instrumentation can be used in frameworks as dnist and dtrace, which replaces instruction with trampoline instruction for branching to instrumentation code, whereas JIT instrumentation can be used in frameworks as PIN and Dynamo-Rio, which detects ROP attacks based on unintended instruction and does not replace instruction as probe-based instrumentation. Further, they incorporated ROP Defender in DBI framework. Here is the diagram of general architecture of ROP Defender. In the figure, we can see that ROP Defender has several shadow stacks and a detection unit which is responsible to enforce return address check. And the reason for the multiple shadow stack is that a process can have several executable threads, and sharing only one shadow stack would give a rise to the false positives. The DBI framework makes sure each instruction the program executes is under control of DBI and as per ROP Defender specific instrumentation code, and then performs return address check. The authors also present the implementation details used in process of detecting the ROP attacks. They use JIT-based binary instrumentation framework PIN and Linux Ubuntu OS. In addition, C++ file which contains 165 lines of code was implemented for ROP Defender detection unit. The main reason for using PIN is that Kohn evaluated the JIT-based DBI framework and showed using PIN can help in achieving best performance. Moreover, there are few exceptions discussed in the research paper which violate the common calling exception. These exceptions are divided into three classes. The first one is the function which does not return exception and implies control transfer before reaching any of the instruction. The second one involves the function which is invoked without the call instruction. And the third class determines different return address during function running. The existence of this exception causes inefficiency in developing the return address protection tool. In addition, the CPU time of ROP Defender was measured to evaluate the performance of the ROP Defender. Result comparison was made between normal program execution and execution with pin without instrumentation. Pin without instrumentation slows down integer and floating computation by 1.58 times and by 1.15 times respectively. Pin with ROP Defender run an average of 2.17 times for integers and 1.4 times for floating points. In order to increase the performance of the ROP Defender, the pin developer focuses on improving the pin framework for increasing ROP Defender performance. Further, the research study found ROP attacks based on return addresses can be detected by ROP Defender. However, check-away presents ROP dependence only on indirect jump instruction other than return instruction. ROP Defender should check the legality of the indirect jumps at runtime for defending the attacks with no returns. However, there are no conventions for indirect jumps target, which make it difficult to defend such attacks without structure informations. Moreover, the adversaries has capability to bypass such defense in case if it issues extended sequence of instructions. The research paper discusses about the design and implementation of the ROP Defender, which is a detection tool for ROP attacks. ROP Defender was created as a new pin tool for enforcing return address protection during runtime. The primary aim was to develop a practical tool which can be implemented without changing the existing hardware. Hence, the concept of binary instruction and shadow stack techniques were adapted for returning address protection. In addition, the paper discusses about the defense technique of ROP Defender, which is used in detecting ROP attacks without relying on side information. Due to flexibility of the tool, it can be deployed in different kinds of applications. Moreover, the paper discusses regarding the performance of the tool and how the tool can improve its performance further. The research paper has many strong points and fewer weak points. The research paper has maintained clarity throughout the discussed topic and kept it unambiguous. One of the strengths of it is that it uses clear topic sentences which guides the reader navigating the argument presented. It also takes reference from diverse backgrounds to make the arguments even more clearer. The research paper consists of implied arguments. These arguments have been tied together with facts, data, logic, and concluded with author's personal experience. The research paper uses consistent logical progression throughout, making it more organized and easier to relate. The consistency comes from the links mentioned and different transitions included in the research paper. Further, the research paper has inclusion of case studies and appropriate evidence from experiments. Experiments lead to building more ideas and provide an appropriate starting point, making the research more detailed. However, the weakness of the research paper lies on the exclusion of necessary factors including scope of study, research question, limitation of the study, and objectives. The objective of the research clearly set an expectation of readers on outcome of research paper, and they can relate clearly to what the author is trying to convey. Research questions further provide clarity on what the research is trying to answer. It is an essential tool for researchers to plan and prepare for the unforeseen challenges. The absence of scope of the research paper has made it hard for readers to understand the depth of the entire research. There is no doubt on how the detailed research paper is with the appropriate use of words, accurate grammar, concise sentence structure, and precise writing styles. In overall, the research paper discusses about the increasing ROP attacks, which are powerful enough to bypass today's security techniques, and presents practical countermeasures to defeat such ROP attacks relying on return instruction. They presented ROP Defender as a countermeasure for defending powerful ROP attacks. ROP Defender has a capability to detect ROP attacks and even provides protection against attacks depending on unintended sequence of instruction. In addition, the concept of JIT-based binary instrumentation and return address on shadow stack was also introduced for the purpose of implementing ROP Defender. Moreover, the research paper addresses the exceptional cases which can take place at the time of execution and demonstrated how to handle those exception cases. And at last, the research paper suggested that appropriate measures are still needed for preventing ROP attacks with no returns. Thank you.